Okay, we are now going to solve this second problem here, 19.3. The problem is in a way similar to 19.2, but now with numbers. Okay, and what we have, two resistors, they are identical. Each one has resistance 100 ohms. In one case, we are going to connect them in parallel, so that's why you see here in this figure A. Now we have this battery and these two resistances in parallel. R1 is 100 ohms, R2 is 100 ohms. In the other case, we are going to connect them in series, so that's what you see here, R1, R2. Now series is along the same line, parallel, we split each resistance in a different line. For both cases, A and B, we have exactly the same battery, potential difference 24 volts. Okay? And then comes the questions. What is the current through each resistor? So what is the current that goes through R1 here? What is the current going through R2 here? What is the current going through R1 here? What is the current going through R2 here? And what is the equivalent resistance of each circuit? Well, the equivalent resistance of each circuit is what we should be doing first. Once we have the equivalent resistance, we just use Ohm's law to get the current that is being drawn, the total current that is being drawn from this battery. All right, so let's start with part A, the circuit that is in parallel. So let me draw it here. We have our potential difference, 24 volts. We have one resistance here, our R1, and the resistance is 100 ohms. And we have another resistance here, R2, also 100 ohms. Okay, so this is the potential VA, this is the potential VB, the potential difference is VA minus VB. Now the potential difference of our battery VA minus VB is that 24 volts. Well, this is also VA, this is also VA, this is also VA, this is also VA, right? So let me write this, VA, VA everywhere on this side. Here, this is also VB, this is also VB. No? We have VB everywhere on this side. So conclusion, which we already knew, the potential difference for each one of these resistance, for the resistance R1, for the resistance R2, they are the same. Okay, good to keep this in mind. Now let's go and get first the equivalent resistance. We already discussed the equation. The equivalent resistance for a circuit in parallel is that equation involving those ratios. 1 over the equivalent resistance, in our case, is going to be 1 over R1 plus 1 over R2. So 1 over that equivalent resistance is 1 over 100 plus 1 over 100. That means 2 over 100, which means our equivalent resistance is 100 divided by 2, which means 50 ohms. So again, you see the resistance, the equivalent resistance in a circuit that is in parallel is smaller than each individual resistance. Now it becomes easier for the current to flow because it has more paths, it has more channels to flow. Okay, so we answered the first question, which was, what is this equivalent resistance? Okay, but there was another question, which was, what is the current through each resistor? Okay, to get the current that is going to be getting out of the battery here, I just have to use Ohm's law. No? So potential difference of the battery is this current multiplied by the equivalent resistance. Our battery is 24 volts, the current is an unknown, and the equivalent resistance is 50. From here, I'm going to get the current that is getting out from the battery, and this current is 0.48 amps. But this is not the question of the problem. The problem is asking us what is the current that is going through each one of these resistance. So let me make this drawing again. Here we have our battery, potential difference 24 volts, right? Here we have our resistance R1, and here our resistance R2, R1 and R2. The current that is getting out from the battery is that I, and I is coming here, but then there is a junction. And what is going to happen at this point? The current is going to split. So here we have the current I1, okay? And from here on, we have the current I2. No? So at this point here, this junction, the current split. So I have here I1 and I have here I2. And this is the question of the problem, because they want to know what is the current that goes through each resistor. Well, since the resistors have exactly the same resistance, it's easy. I know that I1 should be equal to I2, which should be half of that total resistance, or total current, right? The total current that is drawn from the battery is I1 plus I2. Okay? So I know that this I1 and this I2 are equal because I have the same resistance, so it should be just 0.24 amps. So this is the final answer of the problem. The current that goes through resistor R1 is 0.24 amp. The current that goes through the other resistor with resistance R2 is also 0.24 amps. Okay, so this is easy because they split equally. If we had more resistances, if they were not splitting equally because the resistances were different, how would you compute? Well, the way to get current, you know very well. Current is potential difference divided by the resistance. That's what you have to use in your parallel circuit as well. Now, so if I want to use this equation for our resistance R1, what would I do? So the current that is going through my resistance R1 is going to be the potential difference. Well, which potential difference? The potential difference between this point and this point, VA minus VB, which is the potential difference of the battery, VA minus VB. So which potential difference should I put here? 24. Now, which resistance should I put here? Well, I'm studying resistance R1, so I'm going to put here R1. Okay? So this would be 24 divided by 100, and that explains our 0.24 amps. Same thing for the current I2. Okay? I2 is going to be the potential difference between this point and this point. Well, this is VA because this is VA, this is VA. Now everywhere on this left side is VA. Everywhere on the right side is VB. So this again is the potential difference of the battery, 24. What is the resistance? R2. And what is R2? 100. Okay? So as I said, in this problem things are easier because the resistance are equal. There are just two. So we just had to split in half the current that was originally being drawn from, from the battery. But in a more complicated scenario, you would go for equations like this. Okay, so we are done with the circuit in parallel. Let's now go for the circuit in series, which in a way is easier actually to compute. What do we have in the circuit? In series, this, no? The potential difference and the two currents in series along the same line. Why did I say that things are easier? Because the current that is going to be drawn from the battery is the current that is going to go through R1 and is the same current that is going to go through R2. Now, it doesn't split. So all that we have to do for this part B of the problem is to find the equivalent resistance. Now, what is the equivalent resistance? The sum R1 over R2. Circuit in series, the resistance becomes bigger and bigger. The more resistors you add, the bigger the resistance, the harder it will be for this flow of electrons. Okay, so in our case, we have two identical resistors of resistance 100, which means our equivalent resistance will be 200 ohms. So we are done here. How do we get to the current? We use Ohm's law. Potential difference of the battery is equal to R, equivalent RI. Potential difference of the battery is 24. Equivalent resistance we got is 200. And then we get the I. You put it here and you're going to get that this current, now put the numbers and you get that this current is 0.120 amps, which is the answer that you see here. This is the current that is being drawn from the battery, and it's the same current that is going to go through resistor R1 and the same one that is going to go through resistor R2. So we are done. We don't have anything else to do to this problem. Okay, so that's the end of this problem. And now in the next videos, you will see problems that become a little bit more elaborated, that start mixing circuits in parallel and in series. It's just a game. You just go slowly, bit by bit, and you will see that it's not so hard to solve. It's like a game, really.